start off this presentation by saying I'm not an expert. I've only been working in the industry for about 6 months, so I don't really have the expertise to propose solutions in the industry for you, but I wanted to get a conversation going about how we can use these games that I really, really like in order to create more collaboration in the workplace, a problem that I see. So who am I? Again, a lot of you know me, but a lot of you don't. So my name is AlexandraTenney. As I said, I go by Alex. My PR, I did quite a few papers and research about the Trump and Obama cybersecurity strategy, things like that. So I came from a very arts background and writing. So one day I decided that I wanted to understand a lot more of the technical aspects of cybersecurity. So I added a few comp sci courses into my course load that year to try and understand at least the basics. If I was going to be writing policy, I needed to understand the basics. From there, I actually really liked computer science, to my own surprise. I never really considered myself a technical person or a science person, but I liked it so much that I added it as another major and went through that stream as well in conjunction with my political science degree in university. I had a couple of friends in university, 2 of them, who were also really interested in information security, but we didn't really know what information security was. We were just students. We had no mentors in the field or anyone that we knew did this thing. So we didn't know what the skills were or even what a job in cybersecurity would look like. So we all decided to come together and found the first club at the University of Calgary, the University of Calgary Information Security Club. There's quite a few of them here, or at least ex-executives. So we, again, didn't know what it meant to be in information security. We didn't know what kind of technical skills we needed. But one of our friends, one of my co-founders, had heard of this thing called a CTF. And a CTF stands for Capture the Flag, but it is a cybersecurity competition that I will get into later. So we decided if we didn't know anything else, we would base our entire club on this aspect. So I started playing CTFs back in 2019. You can see this was our team at the time, Manzaro's Magpies, a professor's name that we stole without his permission. And we started playing immediately then. And that's just what I based my entire cybersecurity career off of, especially when I was a student. So what is the problem that I've come to speak to you guys about today? The problem is that since my internships and my entry into the industry, I've noticed that teams have a hard time collaborating with each other. And this leaves us worse in our cybersecurity posterity in general. Cybersecurity is a team sport, as a lot of you have heard, but if we're not working together, we're not truly able to secure our organizations. So in actual organizations, I find that teams are really siloed, and they're unaware of the work being done on other teams. This can create duplicate work, duplicate solutions to problems, but also gaps in your solutions because you're not talking about what is or is not being done within those teams. And so you're unable to even know what needs to be done. Generally, I just see a lack of collaboration between teams. There's a lot of reasons behind this. One of the big reasons is there's just a lack of time to talk to other teams. Collaboration isn't a valued output in your organization, and spending that time to get to know people isn't a valued output. So people aren't doing it. Because there's a lack of time to talk with other teams, you don't really understand the skill sets that exist on those teams. And this means that when you're solving problems, you might not be getting the best person on a particular team to help solve that problem with you. And you get used to solving problems with only particular members of your team, usually your internal team. So you might always pick this one person to work with on a problem together, even though their skill set isn't the best to solve that problem. So I talked a little bit about CTFs at the beginning, but ultimately what is a CTF? There are 2 kinds of CTFs that are very popular. The first one is Jeopardy, which I'm going to give you a little introduction into. So Pico CTF was actually the first CTF I ever played. It's made by Carnegie Mellon University, and it's made to try and give high school students and entry-level university students an entry CTF to play in. So Pico CTF is really popular. It's grown quite a bit over the years. And this is what it will look like in any general CTF when you navigate to the main page. You're going to see a lot of challenges, which I will get to in a minute, and you can almost instantly start interacting. So what is a challenge? A challenge is typically a website, a piece of software, an application, or a file that you are asked to hack into. They're intentionally vulnerable, and they want you to hack into it. Hidden inside these applications is something called a flag. So a flag is a unique string of characters that essentially prove that you were able to do what they asked of you, that you were able to hack in. You submit that flag for points. So like an actual Jeopardy game, Jeopardy CTF is broken down into categories. So each challenge is separated further into categories. The main original or typical categories are web exploitation, binary exploitation, sometimes known as pwn, forensics, cryptography, and reverse engineering. Jeopardy has gained a lot of popularity over the years, and they've grown in size a lot. So there's a lot of extra categories that sometimes get added into these CTFs. Common ones that I've seen, but definitely not all of them, are networks, programming, open source intelligence, OSINT, or just a missed category as a catch-all. So before I continue, I want to get something straight. I love Jeopardy CTFs. Again, I said for the majority of my years playing CTFs, I was playing purely Jeopardy CTFs. It's accessible, and I think it really helps develop skills that are required in a lot of technical cybersecurity fields. So I'm not trying to say in this presentation that Jeopardy CTFs are bad. Their pros in terms of collaboration are that it helps have multiple team members on a team to solve different challenges and bounce ideas off of. It's also unlikely that one person is good at all categories. Someone who's really, really good at binary exploitation might not be as good at web exploitation challenges. A lot of the skills are antithetical to each other, but also it's just hard to have that depth in every single category. And lots of people are playing in them. So if you wanted to play in a Jeopardy CTF, it's likely that people that you already know or members of your team have already played one before or can quickly understand the idea. The cons of Jeopardy CTF is it's not really like the real world. It's not very dynamic. You're asked to simply hack into one thing, and there's no greater gameplay to that. So it's quite static of a game. And it's not great at cultivating teamwork between members. I have seen a lot of very excellent hackers, a lot of excellent CTF players who can do incredibly well in a Jeopardy CTF all on their own. So they don't need those other team members to do quite well. So up on the screen right now, I have two screenshots from a website called CTF Time. CTF Time is a website that tries to cultivate all of this ongoing CTFs at a given time. So these two screenshots on your guys' left is all of the Jeopardy CTFs that happened in 2023 that are on CTF Time, and on your right, all of the attack defense. So all of the Jeopardy CTFs do not fit in one screenshot, and I could not count them. I tried. But there are over 400 Jeopardy CTFs that happened in 2023. So it's very, very popular. On the right-hand side is all the attack defense CTFs that happened in 2023. There are 18 on that screen. However, only 7 of them were playable by everyone. So plenty of them where you had to be in person at an event to play, like a B-sides or something, or you had to qualify, and you had to be a finalist to actually play these. So only about 7 attack defense CTFs are playable during the year, which is why part of the reason why it's much less popular. And I just wanted to show how much more popular Jeopardy is. And before I continue, I wanted to give a shout out to giants whose backs I stand on. So these are 3 attack defense CTF organizer groups that are building attack defense CTFs that are playable by everyone. So Star CTF, their CTF is actually tomorrow, if anyone wants to try a late registration. They're one of a big German team. Actually, all these teams are German, ironically. Eno Wars actually makes another separate CTF called Bambi CTF, which is geared towards beginners trying to get an attack defense CTF, and also Faust CTF. Faust CTF is where a lot of the screenshots from this presentation come from. Part of that reason is Faust tries to open source all of the infrastructure for these games and tries to make it really understandable. Also, Faust is just the most recent attack defense CTF I've played, so it was the most readily available for me to take screenshots with. So how does this game actually work? When you log in to Jeopardy CTF, you're going to get this page, this web page, where you're basically instantly able to start playing. In stark comparison, when you navigate to an attack defense CTF, there's just a bunch of text on the screen. None of this is actually allowing you to play the CTF in any way. You only get a VPN config. So this is a network diagram taken from SAR CTF that tries to explain how this game works. But at its core, in a two-sentence description, everyone gets an identical vulnerable machine. Every team gets an identical vulnerable machine, and on that machine, there are services running, which are the vulnerable parts. All teams are trying to attack other teams to gain flags from those services and to defend their own machine. So there's a typo in this. I only noticed it last night, so I apologize. But I wanted to really drive this point home. If you get lost during this presentation in me explaining what an attack defense CTF is, what you need to remember is that all teams attack each other and every team has an identical machine. This statement will probably get you through the entire presentation. And so I'm going to take a sip of water while you all sit on that. So to try and demonstrate the dynamicism of this game, I created a flow chart. So as it is right now, it's very overwhelming. And I'm going to try and go through the flow chart piece by piece and explain how this game works. So you don't have to understand it right now. This is just to see what we're building towards. So when the game starts, the network is closed. But what does this mean? I created a little diagram to try and explain this concept. So imagine in this scenario that you are team one. You have suspicion somehow that team two has a web server running on their machine at port 80. So you might try and navigate to that web server to see what's on it. The game router is going to drop that request and block it. You cannot actually see their web server yet. So that's what it means when the network is closed. No teams can interact with other teams' machines or services yet. You can only interact with what is on your machine. So you might be thinking, how do I play this game if no one can interact with each other? And you are going to start with something called source code analysis. So I said earlier that you get a VPN config to start interacting with this game. You get root administrator access to your team's machine for this game. So the first thing that you're going to want to do when the network is closed and when this game starts is you're going to want to start understanding the services that are running on your machine. You're going to want to understand them at a very deep level. So you might first off try and find where all this source code for these services is stored. And then you're also going to want to understand the ports that those services are running on, so you can predict what ports the other team services are going to be running on. Again, the machines are identical. And you're also going to be able to look through this source code. So in this instance, having the skills to read through code is particularly important, but you're going to want to understand the logic behind how these different services work. So these are just two examples of two services. One is from Faust 2022 and one is from Faust 2023. So these are the type of services that might end up being running on the machine. The one on your guys' left is just a web server or a website. And then on your right is a binary that you're able to netcat into and then interact with. It gives you a menu. Something to note about these services compared to something that you would get in a Jeopardy CTF is they tend to be quite well made and full-fledged. So you're looking at something that is like 3,000 to 4,000 lines of code and is actually a fully interactive service or application. So that's a big change between the two types of CTFs. So now that you've understood how these services might work and how their logic is laid out, you might find some flaws in the applications. Again, they're intentionally vulnerable, so there are intentional flaws built in. At this point, in order to defend your machine from other people before they can access your machine, you're going to want to do something called patching. So this is an example of a piece of code that essentially allows for a SQL injection. On the top, you can see that we are concatenating user input without sanitizing it, which in this case, because it is running a SQL query against a database, would allow for a SQL injection. So that is unpatched code. You during the game might notice that this is vulnerable to a SQL injection and change it to something that is below, which does sanitize the input and doesn't directly concatenate user input into the query. That would be indicated as patched. You might also understand the exploits that you would be able to run against other teams. The network is still closed, so you can't yet run them against other teams, but you are able to start understanding the logic and the flow that your exploit is going to take in order to attack against other teams. And you can test against either your own machine, or you can bring the services up locally on your local computer to test that flow yourself. The best way to secure a service would be to simply take them offline. Kill them. No, if no one can access your service, it's not vulnerable at this point. So you might be thinking, this is pretty anti-game. That's not the point of the game, is to just turn off the machine and simply not play. So to avoid this problem, organizers of attack defense CTFs have implemented something called SLA, which simply means uptime. Your services have to stay up during the game or else you actively lose points. So when you get into your machine of the game, you might notice that not all services are running. I have a feeling I'm missing some slides. No, I'm not. You might notice that not all of your services are actively running. You're going to want to get those up as soon as possible in order to make sure that you don't lose these SLA points when the network opens. You're also, if you create a patch, you're going to have to recompile or rebuild that service and redeploy it, or else the old unpatched service is the only thing that's running. So you might be using skills like pipelining. You might have to understand Docker and Docker Composed in order to do this, but you want to keep them up. So the network typically stays closed in an attack defense CTF for about an hour. So you have to do that all in an hour. At this point, you have 8 hours of your network being open. So now teams can interact with other teams' machines, and you can start exploiting against them to gain a flag. So this is a snippet from the scoreboard. I'm going to go into the scoreboard more in depth later. But what's important here is I talked about maintaining uptime earlier in SLA. And the first thing you're going to see is you're now going to be able to see if the game server thinks that your services are up or down. So in this scenario, this is from Faust again. Your options for services are that they can be up, they can be faulty, they can be recovering, or if you somehow manage to remove the flag from the service, because they don't want you doing that either, your flag cannot be found. So I mentioned it was really important to try and get as many exploits done during the network closed portion as possible. When the network opens, you're going to want to try and exploit at least one team as quickly as possible. And this is because of first bloods. First bloods exist in Jeopardy, but they're very important in attack defense. Essentially, a first blood is the first team who is able to exploit a service or a vulnerability. Often you get extra points for being the team to first blood a service. Sometimes you just get money, straight up. So it's pretty important to try and do that as quickly as possible at the beginning of the game. So that now that the network is open, teams are actually able to interact with each other's services, which means there's now actually network traffic that is running through your machine. So at this point, you might want to do some packet analysis. I know there was a Wireshark 101 workshop earlier yesterday. So Wireshark is a great tool to do this. You also might do it with your own tool, but you're able to inspect packets from traffic to particular services or just your whole machine and start to understand how other teams are interacting with your service and how they might be trying to exploit something. This is from Faust 2023, and it's actual network traffic against a service that we were running at the time. When you're analyzing packets, you might not have been able during the network close portion to understand what the exploit was in the code, but you might be able to see how other teams are actively exploiting your services. And then you might be able to do something called exploit reflection. Exploit reflection is a little bit of a complex topic, so I created a diagram yet again to explain this topic. So in this scenario, your team would be team 2. So team 1 runs a SQL injection against team 2 on their web server. In this scenario, your team did not know there was a SQL injection running on that service. So they're going to get a flag back because your service was unpatched. But you're now monitoring your network traffic. So you're going to notice as team 2 that they ran a SQL injection against that service. And you're going to notice, oh, there's a SQL injection. So you might run it against team 3, where you're now able to get a flag if they haven't patched it and successfully reflect that exploit. This is a tool that was made by the European cybersecurity team for the International Cybersecurity Competition of 2022. The first one, it's called Tulip. It's based off a tool previous to it called Flower, but it's specifically made for attack defense CTFs. Essentially, it's a packet analyzer that specifically made for attack defense CTFs that will tell you if there's a flag, and it's got built-in features where it's able to run through the packet and copy that as a script to either Python requests or Python prone tools. So people are really good at reflecting exploits really, really quickly. Detection and response. So again, there's network traffic now running through your machine, and people are interacting with your services. They might be intentionally trying to take those services down. The services are vulnerable, which means that sometimes they're a little funky to deal with. And also you have just a machine that you need to deal with keeping up. So you might want to go through system logs or Docker logs to try and diagnose behavior of services. And you also want to watch your machine. This is 2 screenshots from my team's tooling server. And we actually run metrics against also our tooling server because it fills up with packets really, really quickly. And we have to make sure that it has enough storage. So in this scenario, we are using the Grafana Loki Prometheus stack simply because it's open source and we like it to monitor these Docker logs, system logs, and also machine metrics. So just to bring the 2 different flowcharts together that I've discussed so far, because I'm going to start talking about how they interact together. And I don't want you to get too overwhelmed now that there's so much on the screen. So I talked a little bit about exploits, but I was talking about them being very manual. At this point in the game, you are going to need to automate your exploits or script your exploits. And to explain why, I need to explain another function of the game. In the game, there is something called a tick. And a tick is essentially a cycle of the game loop. Ticks typically happen every 1 to 2 minutes, and every tick, flags are replaced on each service. There's also something that happens during the tick where a script called a checker will go to all of your services and make sure that they are still up, functional, and that the flag was there. So why do you need to automate? If you think about it, there might be 200 teams playing this game. There also might be, you now also have to run an exploit every 1 to 2 minutes against 200 teams. That is not feasible by manually trying to exploit things. So you're going to have to program, usually in Python, but any other language that you're used to, and program these exploits to make sure that you're able to successfully get these flags and then submit them to the server. To aid this automation effort, attack defense CTFs always provide a JSON file, also often called teams.json, which provides you all of the team IPs and also a little hint to where flags might exist on the vulnerable services. So if you're running a SQL injection and you're trying to steal a user's password, maybe it was stored in plain text on a database, it's going to tell you which user you have to steal that password from. So this is used so you can actually put those variables into your exploits when you automate them. Finally, from doing your packet analysis and your exploit reflection, you might now have greater insight into what is vulnerable about a particular service. And again, you still have to defend your own machine. So you have to patch those exploits and figure out where they exist in that source code to change that source code. I talked about the scoreboard a little bit earlier, but this is the entire scoreboard, and I'm going to go through it piece by piece to explain how it works. But typically in an attack defense competition, this will be up on a monitor the entire time because it is a very important feedback on how you're doing in the game and how other teams are doing. So at the top of the screen, you can see all the services that are running on all the machines in the game. And as I talked about earlier, you can also see everyone's services and whether they're up, down, faulty, etc. For each individual service, you get 3 scores. So the top score with the little fire emoji is actually your attack score. So this is related to how many flags are you stealing from other teams for that service and submitting to the server successfully. The second, the middle score is your defense score with the little chess piece. So this, in this particular scenario, is actually a negative score. So for every flag that you lose from that service, you lose points. And then the bottom score is your SLA, your uptime score. So in this case, it is the seconds that this service is up and running as expected in this game. For each service, those scores are added up, and you get a total offense, total defense, and total SLA score. And then based on some function that the organizers will decide, they will calculate your total score. And that indicates how well you're doing in the game. So I know this seems really, really complex already, but how complex can this game get? And the answer is very. There are people and teams out there that are very good at these CTFs. So I talked a little bit about it throughout this presentation, but pre-built tools is really important for doing well in this game. So this is another example of a pre-built tool my team uses. It's called Uptime Kuma, and essentially it does is it checks that our services are up and running as expected, and it's a little quicker at that than the scoreboard is. So it gives us indication if we try and build a patch and it breaks the service, we will immediately know if it's broken. This is an example of a tool called Attacka, which essentially helps aid the automation of your exploits. So you're automating exploits during the game, but they're running every 1 to 2 minutes, maybe you have 8 exploits going against 200 teams. It's really essential that this code is efficient and is submitting very fast, and then that they're all running in conjunction quite well. So Attacka is a pre-built tool that helps. It says run exploits fast, essentially, because you don't want to miss submitting a flag after it's old, even though you already exploited it. That sucks. This is a screenshot of a talk from the Faust CTF organizers that they did for an HA proxy conference. So one of the strategies that goes above the game that teams have started to try and implement is if you can let no one hit your machine except the game server that is checking if your services are up and running, you win. You've done it. So they're trying to fingerprint the game server and figure out who exactly is making those requests and block every other request. So the organizers then have to respond and try and make it impossible to fingerprint this game server. So there's quite a bit of give and take between the competitors and the organizers and how they build this competition. So who are the players that I see actually playing in this CTF in an organization? Obviously the red team and the blue team. It's an attack defense CTF. You want your attack and you want your defense. but also with all the packet analysis and the different network traffic, the network team, developers who are doing source code analysis and also patching, DevOps for the deploying and the maintaining of uptime, and also QA to test your patches to ensure that your services are still up and running. I think we should try this game in businesses and organizations. Attack defense CTFs are really good at forcing collaboration between a team who is playing. You have to understand the skills of several other people. If I, as a red teamer, is able to attack a service, I might not know how to patch it. I might not have that great understanding of code. I also don't have maybe the greatest understanding on how to spin something up and how to maintain uptime between services. So I think attack defense CTFs are really great at understanding the skills of different teams and employing them in a way that is safe. You're not going to break prod if I try and deploy a patch and find out I can't. But I am going to learn that there's someone else in my organization that is really good at doing that. And I can call on them the next time that this happens in a real world scenario, and I know that they can do it. So there's a lot of games in cybersecurity that we use to try and create this collaboration and do run-throughs of our organization and in scenarios of an incident. But why is this different? So people know tabletop simulations, tabletop exercises. I find that tabletop exercises often call upon very senior leadership. They're not calling on the individual analysts who are doing that hard work. It's also it's a simulation. It doesn't actually ask you to physically do these things and actually replicate the real world that well. There are hard games like Elevation of Privileges or Backdoors and Breaches, but these are very domain-specific exercises in cybersecurity. So they're testing your incident response capabilities or your threat modeling capabilities, but they're not calling from all those teams, and they're definitely not calling for teams who are not in cybersecurity, like your developers, like your quality assurance. I also have to give credit where credit is due. There are organizations like Hack the Box and Huntress who build CTFs for companies who want their teams to play in something like this. Typically, and I've yet to see it, they are Jeopardy CTFs. And again, I love Jeopardy CTFs, but I don't think they're as good at collaboration as an attack defense CTF. So then the question is, how does this fit? How does this fit in a workplace that doesn't value taking time away to build this collaboration between teams? Is this something we could even do? That is a question I have for you guys. I, again, don't have enough experience in industry, but I wanted to propose the idea that we start doing these games in industry to try and gain better collaboration. So I invite you to come talk to me throughout the conference or come up to me after this talk and tell me what you think. But this is my question for you. That's the end of my presentation. Does anyone have any questions?
Well done. Great message.
Okay. Awesome. Thank you.